Hey everybody, welcome to Missing Links with John, Brock, and myself, Stephen King, where we discuss what's missing in Web3 architecture. This week, we talk about indexers, what they are, why they're important, and why they're largely missing in Web3 right now. For feedback, please go to missinglinks.fm, send us an email, give us some feedback on what we discuss and what you'd like us to cover next week. All right, let's get into it. All right, so this week we're going to talk about indexers, and Brock very appropriately is wearing his The Graph t-shirt, highlighting. He did it just for this episode.
Promise it wasn't planned. Yeah.
It just worked out. It's the universe. So you guys are wizards on this, and we got some experience having some fun with Imbrex building this as a byproduct. And we found out that it was probably more important than we gave credence to, probably more important than the actual product we were building at the time. And so I thought it would be good just for you guys to start and, not really dumb it down, but just kind of explain what an indexer is in Web 2. A lot of people know about Google and how it indexes the web, but I think more so that it's a search engine. And so it's kind of two different things. So why don't, I don't care who takes it first, but if you guys could both explain it in your own unique way, I think that'd be a good place to start.
Go for it, John.
Let's go for it. Okay, so how I like to describe any kind of indexer in the simplest terms, think of it as the fastest way to find some end result. So given whatever information you're indexing, it's a set of rules that help you kind of find what you're looking for in the fastest way and kind of point to that, be it a website for a recipe with certain keywords, or maybe something on the blockchain that is linked to a certain account. So those are kind of, I think, the simplest ways you can describe an indexer in maybe 2 sentences. Brock, would you like to add to that?
Yeah, I think of it as a way to, basically digest a larger set of data into a smaller set of data, so it's more easily accessible.
Think of them as crumbs. Think of it like if you ever do long treks on a GPS, you have geocache certain locations along the path. Think of it as geocaching, but on a bigger scale.
Yeah.
So why doesn't, this is a question, why doesn't Web3 have, let's say, a good indexer, right? So Google, I guess they had the know-how and the resources to index the web, and obviously that was a derivative of many predecessors before it. But Google was kind of the one that took. But in Web3, why don't we have a way to just go into a search engine and say, okay, let's say I've got a decentralized parcel, and I want to know, what the comps are. Something as simple as that. That information is really difficult to find. Even on OpenSea, the data, it's sort of there, but it's not very clear. So. I know the Graph is working on this. Actually, if you could explain a little bit about what they do. I know they've got more of a decentralized model, and then how you could kind of improve upon that.
Yeah, so I think the one thing I could say about that is that I don't know much about what Graph's doing, but I think the reason why it's so difficult is because one of two things, kind of the state machine where the information lives between different nodes, whereas everything for Google lives on their own. They control it, so they can pick how much they want to index and how much they don't want to index. Whereas something that's on chain, when you're looking at a combination of archive nodes, fast nodes, and things like that, it's really hard to kind of get that information because it could change on the fly with whatever is the next block or whatever consensus is next. Brock?
Yeah, I think some of the big problems with the net scene come around a lack of standardization. It's the data, specifically in Web3, that you're trying to get at. Take your example of getting comps. You have to first understand what what the thing is, which in this case would be like an NFT. And then you have to figure out what is similar, like find another NFT that's similar. And by similar, you're really meaning like the off-chain attributes of that NFT. So you're having to mirror on-chain data with off-chain data. That off-chain data may or may not be in a standardized format, may or may not be accessible. So trying to like bridge all of that into one cohesive way, and then generalizing it is much harder.
So you're basically, when you were visiting a couple weeks ago, we're going through, you have you're running an ETH node on your Mac, and so you're able to just kind of jump in and use certain keywords to find information. So if you wanted to find what a parcel sold for, did you put that logic in, or can anybody do that today? In other words, are you creating like a database of a database of the blockchain, and you're putting the logic in and you're kind of customizing that process? Or if you're running a node today, can you, not easily, maybe not a guy like me, but guys like you, can they pretty easily go and fetch that data?
Yes and yes. So like what I'm doing is I'm trying to figure out how to generalize this by first taking, say, the Ethereum blockchain and then indexing all of it in a raw format into a PostgreSQL database. So it just lets me run SQL queries against it in a decompressed format. And so from there, I can say, okay, I want to look up the most recent NFT transfer for this contract address and this token ID. And I can essentially work from that and like the scope of the transaction that I was in to figure out what it was worth when it got transferred. So you can kind of pull that apart from on-chain data. But that being said, you can do that exact same thing by just connecting directly to an Ethereum node. What gets difficult with just an Ethereum node is in the aggregate data. So if you wanted to say, I want all like the aggregate volume for all NFT sales of Decentraland, running that query against an Ethereum node is not going to be quick or simple.
Why?
So the blockchains are really good at storing data, not super great at accessing it. So it's all stored and compressed, and so you can like look up an individual transaction and the individual block, and they have helpers to like try to say, okay, between these block numbers, I want to look up a transaction or an event log that looks like X. But so to answer the question of like, what's the volume of Decentraland, you would have to go back through all, whatever, 14.5 million blocks, find all the matching events, pull those out, aka index them, and then run an aggregate analysis against that.
Okay. And that's not standardized? Is that what you guys mean by that? Like that process is not standardized, or like the actual searching mechanism itself, like the actual words that you're going to find, that's not
both.
Okay.
Yeah,
both aren't standard.
Because if I go, so this I've seen this happen and tweeted about. If I say I need to know every transaction to the smart contract for Uniswap for some type of currency pair, and I say I want it going back from this block to that block, you can actually crash the node because it takes just so much information and processing power. Like there's been times where even on my own machine, going back 1,000 blocks, it's not even to Brock's point, it's not even standardized. I can go back maybe 2,000 blocks, it's fine. But once I go back, the next 1,000 after that, complete garbage because it's just.
Well, it totally depends on what's in those blocks. Like
exactly,
1,000 blocks during a down period is totally fine.
It's nothing compared to 100 blocks in the peak. Right. And to your point, Brock, what I was thinking about is that everything comes down to relationships. And I think that's a huge thing. I think about it more from a compliance perspective. And at my last job, I was so into like graph theory and like using like Neo4j, you can actually build simple relationships to where the primary keys are the end. So pretty much if you have a question, the graph can quickly transverse through the nodes in the graph. And depending on the edges in that graph that represents actions or relationships, once you hit a dead end node, that node will have an ID and you do a simple lookup in Postgres. And that gives you what you need.
But
Or attached nodes to a single node can be quickly looked up on the primary keys.
so you're basically you're putting it into Postgres. So you're searching.
Yeah.
Okay. So what is that process like? You're taking every single block and just putting it into your own database, and then are you doing anything else other than just querying what you're looking for?
So what I was so how I do it was I take all the transactions, pull them into Postgres, then build the graph off Postgres, and then almost like how Tesla uploads video every day from your Tesla to determine and retrain its model, it would rebuild the graph in certain segments and lock it. So then when a query comes through, you can query the graph and then do a quick primary key lookup, and it's much faster, and you don't have to worry about re-indexing or even sharding your database at that point. Well, it depends on the size of volume.
Yeah.
I don't know how big the primary. I don't even know at like a primary key lookup with a database of like a terabyte in Postgres. I don't know what that performance-wise looks like before you do partitioning.
So the current one I have is about 3 terabytes, and the primary key is still plenty fast.
What, like in seconds or milliseconds?
Like sub milliseconds, yeah.
Okay. So
Yeah.
yeah, if you have a graph, then that graph. So imagine you have a node, and that node has representations of certain, let's just say, users of a certain transaction. You quickly just aggregate those IDs, hit the database, sterilize it, and send it out.
So
How
are you
yeah,
using?
how do you update? Are you guys updating the database in real time, or do you have to keep porting it over?
You can do Postgres events. I've seen things done like that where you do every time there's an insertion. Um, you would pretty much fire a separate event that would tell, oh God, I forgot the terminology, but it would tell Neo4j to do some kind of join. You would pretty much detach the graph, make an update, and then reattach it. So when it's detached, it's almost the equivalent of the block has not been mined yet. And then when it's reattached, then it's like confirmed, and then you could have rules about attachments to. It's like validity, like verification almost. There's ways of manipulating it, but that's how I was thinking of it, because reorgs are a huge issue, and let's not even get into reorgs. Like that just is a nightmare. That's a nightmare.
So let me ask this, and Brock, you're about to say something, but why has nobody done this yet? Why hasn't there been some kind of, maybe it's not an ERC, not protocol. What are the submissions that you can put in? What are they called?
The
Yeah,
EIP?
please.
Yeah.
Yeah.
Yeah. So has there been one in terms of search, or is it so specific? Because Brock, you sent a great article on, I don't know if it was a girl or a woman yeah, I think it was a woman that's trying to do this. But so we built this, right? So our last company, we were trying to create an MLS using IPFS where people would actually, entities would own their data rather than send it to these centralized aggregators. And we're a bit early on that, but we actually had to index the information. And so, you guys stood that up, pretty quick. And so is it just standardization? Is that the issue, or is it more boutique? Everything is going to be sort of segmented to very specific use cases?
I think in
Both.
in that particular use case, I can remember the MLSs just having to write templating rules just to get things standardized so we can disseminate it through the indexer. And that I think was 80% of our issue most of the time, because values wouldn't go they wouldn't parse out right. And even when we would send directions on how to kind of give connect it and give standardization, I don't think we had enough validation. I would say we didn't have enough validation in the code to like. I don't think the code was designed enough in a way to push back if there was a bad validation.
Yeah, it wasn't enforcement.
Yeah, there was no enforcement because if a bad doc came through, because it was just a stream, if I remember the indexer, it was just a stream. So anything that came through the stream, if it was a bad doc, then even though all the rows were right and one was wrong, we would have to throw that out. So.
Well, I guess my question is, so, okay, let's say things are being built now. It's not too early. Let's stick to the MLS. Let's say that they put all their real estate data. Let's say that Zillow, it becomes decentralized, or there's another. So obviously the hard data itself, right? You could put that on IPFS. So
Yep.
really just you're just pointing to IPFS. So if you look up the transaction, you're going to just put the transaction ID, you're going to transfer that over to Postgres. And then how does the search mechanism work with all that? And how does all that work without extreme latency, right? Because you're jumping around now from different nodes to different databases. It just seems crazy.
Yes, it's a re-centralization problem. Like in order to search, you have to re-centralize the data. Yeah.
So we're going the other way now.
Yeah.
Yeah. Couldn't you
but
could you make assumptions and cache those?
Potentially. So like one of the things that I'm doing with my data set right now is providing like an NFT lookup. So you can look up an individual NFT. And what it'll do is it'll not eagerly, but at request time, go fetch the metadata for that NFT from wherever it's stored, whether it's IPFS, some like third-party server. And so like the next iteration of that would be then caching that data. But if you're, say, specifically trying to build an NFT API, some things that you can do that are smart is like assuming the top 100 traded NFTs are going to be the ones that are most looked up, and you preload all of those into your cache. So you can start to do some of that, but you're still having to go grab all this data and centralize it to really make it searchable.
So the graph actually may be onto something then, because they're creating sort of this node system, and it sounds like it sounds like it would be beneficial, because if you've got one Brock that's caching this, that's great. But if you've got 10 Brocks that are caching this, then the closer Brock that I'm near is it's just gonna improve things, right? Are we just talking about in terms of scaling it? Is that how it's going to go? Or
it's that, and then also the graph. What's trying to novel is they are like, by participating in the network, you as Steven could be running a graph node and you are indexing MLS transfers. But you also want to access token transfer for an ERC20. You can request that from like the broader graph network as long as somebody's indexing it.
Yeah, I'd like to see this done without tokenomics or without a token. And so do you need to incentivize people to actually do that? Like, I know that they're using their token for curation and things like that. And then there's a couple actually people that are trying to do this now. Is there without
what's
just
the incentive? What's their incentive? That's the problem.
Yeah.
Like very few people run. Yeah, I was going to say very few people even run like Ethereum nodes without also mining. Yeah.
Yeah. And once mining's gone soon, that's another question just in the community itself. People are like, are you going to see a collapse in the number of active nodes that are actually will be validators for proof of stake?
Yeah. Well, okay. So then you'd have more of a centralized model, and then instead of using ads, I guess you could charge people for you could do like a B2B type of deal where people that need that data in their business, you charge them, but just regular retailers or consumers, you just let them search for free.
Yeah.
how's this not turn into then Google or Facebook?
Well, that's the question, John.
Yeah,
You know,
because to play devil's advocate, if you're already gatekeeping data, how's that different than what they're doing already?
well,
Well, I think the idea there is to not gatekeep.
Well, exactly, but how? So the question, I think it's a self-fulfilling prophecy a little bit, or a circular argument. How do you incentivize to run infrastructure without tokenomics, but people can afford it without having to gatekeep information in a paywall?
I think it's more the you don't charge anybody like using under a certain like request limit, and for bigger companies that want to use it in a professional sense, you charge them.
So you're
And so
basically,
it's a freemium.
yeah, you're running your own, you're running the infrastructure. You're just, the data's out there for everybody, but you're just doing sort of the handoff, I guess, so that you're kind of normalizing the data, right? Is that what you're saying? You're getting paid to normalize the data?
Well, I'm saying, like, what if it's like a freemium? I don't know how you pronounce
Yeah.
that, but what if it was like, so let's just say Barack and I both have 2 nodes, and we're like, we really need more nodes to make this better, or something like that. Stephen, you're running a multi-million-dollar company. Let's just say we give you if you run nodes, you'll get a discount, or like if you help with the network, you get a discount. So then again, now we're getting in, we're now getting into economics of the nodes, which is an issue, because how do you enforce that?
Well, no. Well, let's say that it's Brock's company, right? And then I just want to run. I want to run one of these nodes, and Brock lets me take the vig, right? Or he takes a piece, but also I take a piece too. So sort of, I'm this. It's sort of like Uber, right? I'm a subcontractor almost of Brock's sort of umbrella organization. Now it's not. It's kind of a hybrid, right? Because it's kind of decentralized, like the data's out there, but Brock is initiating the legwork of, maybe I'm using the wrong terminology, normalizing, whatever we're kind of porting the data from,
aggregating,
yeah, so that it's actually searchable and it scales. And
so I think the other model here though that could work is, and now we're like getting into like business side of things, but I think say we're running a data aggregator company, and we want to, it's free for standard use through like our search engine, but if you want like access to the raw data, you got to pay us. What you can do is a licensing model there, so that the company paying us is, in order to access that data, they have to run a node as well. So it like hardens our infrastructure, and that's the only way that they can get the data.
It's funny because we're going to put this out in the public, so I'm not really sure what what we should put out and what we shouldn't. But I guess it's open source. People are basically going to be listening to us building a company, but that's okay. But I like that. That's a good idea, and that's it's going to be interesting to see how this shakes out. On the next one, I want to talk about IPFS, because I want to see, like you guys, what you know how to do with the database blows me away. I'm curious how IPFS is going to fit into all this. And, I get updates from them, and, we've been following them for a long time. Yeah. And so I have questions around just the company itself. I have a good understanding of it, I think, but also like IPNS, like how that fits in, and so, I thought about, though, John, or maybe it was you, Brock. It was one of you, but we were talking about how we were not indexing the data. Do you guys remember OrbitDB?
Oh yeah.
Yep.
Well, what did we use that for?
So OrbitDB is this. Caching, well, it's basically a library on top of IPFS. So using the IPFS protocol, you can run effectively a database decentralized.
Okay.
Oh, that was you. Yeah, I do remember that.
Yeah.
Well, let's tie that into next week. So we'll wrap up with next week we'll tackle IPFS in actual, I don't want to say data itself, because but I guess
it's a much bigger conversation. Yeah.
Thicker data sets.
Yeah.